Hello everyone, and welcome back to another video. In this video I want to go over all the developments in my 3D printed RC plane project that have happened since the last video. The design in the last video might have appeared like it was mostly done, but really it was quite far from completion still. Actually, I've gone with a full redesign, more on that a little later. So I wanted something to test my manufacturing capability. I wanted something to fine-tune my print settings and just sort of go through the experience of building something before I try to build something that I've designed myself. To do this, I found this model for an FJ4 Fury on Thingiverse. This RC plane is designed for lightweight PLA printing and the exact same EDF motor that I'm planning to use, so it is pretty much perfect. So I decided to build this plane as a sort of test to figure out if my printer, my print settings and I are capable of putting something together that can actually fly by the end. I had to buy a little carbon tube for reinforcing the wings, some servos and the EDF motor itself. Other than that, it was all just filament and stuff we had in the workshop. A lot of the parts used for the Fury were basically prototype parts. I was still figuring out what settings to use, what thickness to make the walls, what infill ratio to use, testing with no infill ratio at all and instead printing things in VARS mode. So a lot of the parts that ended up in the first version of the Fury were just sort of good enough, I think, but quite far away from what I would be using for an actual flying plane. But everything still fit together, and we ended up on the field with a fully built FJ4 Fury, ready for its first flight. Now the first flight went less than ideal. As it turned out, the center of gravity of our Fury was way too far back, and the thing was extremely tail heavy, leading that shortly after throwing it, its nose immediately rose up to almost 90 degrees pointed into the sky, and the plane more or less started hovering in the air. It has about 1 kilogram of thrust with a fully charged battery and weighs about 900 grams, so when the nose goes right up, it can actually slowly climb. However, it was very slowly falling over, and so it quickly went from sort of hovering to slightly landing on its side like a SpaceX rocket. Because it was landing with such a slow speed, there was actually very little damage done to it from this crash. The only damage was in one of the wing parts, and the damage was very quickly repaired with superglue. For the second flight, we modified the canopy to allow our battery to go much further forward to fix the center of gravity. And the second flight went phenomenally. The battery might have been a bit too far forward because I needed to use a lot of elevator to get the plane climbing, but other than that, it was pretty much perfect. It handled nice, it handled the speed, it had a nice turn radius, it had no weird stall tendencies. Pretty much everything about it was just fine, as if I've just bought this plane out of a store and just flown it for the first time. Even the landing was pretty good. I sadly don't have any footage of this because we were basically alone on the field that day, but I can just say it flew really well. After the second flight, I decided to charge up the battery again and go for a third one. This is where things took a bit of a turn. I'm not entirely sure what happened, but it might have been a combination of things or just one of them alone. The plane was being thrown at a pretty aggressive angle, one where I would have to pretty much pitch down instantly to prevent the plane from stalling, while I was expecting to have to pull up after throwing the plane. There was also quite a lot of wind that day, and it's possible that the plane got hit by a gust of wind, and it's possible that perhaps the center of gravity was just a slight bit off since we moved the battery further back again after the second flight, since it felt a little bit nose heavy. No matter what happened, the plane did again stall, and because its center of gravity wasn't as tail heavy as before, it didn't stay with its nose up in the air. It fell over and ran into the ground with the nose first, which resulted in the thing getting torn apart into many small pieces. After taking a good look at it, I decided to repair the plane because, as it turns out, there's only very little damage to actual parts that would have to be discarded. The nose section and one section of the wing were unrepairable, but everything else could be reused. So I printed out a new nose section, printed out a new wing section, and glued everything back together. And right now the plane is in usable condition again. Because it is winter, we are not flying it, but as soon as spring rolls around, it is ready to go again. So with the FJ4 Fury project complete, I now felt confident that my 3D printing settings were good enough and that I'm actually capable of putting together a working RC plane. So I went back to work on the CAD model of the F-111. And we'll get into what exactly I did to that model after this message from our sponsor. I'd like to thank our recurring sponsor, PCBWay. PCBWay offers professional PCB manufacturing and assembly services of all shapes and sizes, whatever you need for your project. You can quickly get a quote by just telling them some basic information about what you need, and if you like what you're seeing, you can upload your design files and go straight ahead to payment, fabrication, and then shipment. And even if you don't need a PCB-specific project, you can still find some very good options here, because PCBWay also offers CNC machining, sheet metal fabrication, 3D printing, and even injection molding. If any of this sounded interesting to you, then please go ahead and give PCBWay a try. I took a very good look at the existing model for the F-111, and I decided that I really don't like the overall shape of the model. Things were just slightly off, detail was lacking, and things weren't just looking good enough for my standards anymore. So I decided to completely restart from scratch. That model was the very first CAD model I've ever made, and it shows. And the second model that I've made, I used what I learned making the first model and also paid closer attention to details, so the second model came out much better than the first one. The second model is far more detailed and has a much better looking shape in my opinion, and this is the model that I have gone ahead and started building. The overall idea remains the same, the swinging mechanism still works the exact same way, and the arrangement of parts inside the fuselage is still the same. The EDFs have been moved slightly forward, and the landing gear has been slightly repositioned, but everything else is still the same idea. It's just that I made a much more nice to look at and more accurate model that would still work well as an RC plane. After I had finished the most important parts, that being the outside, and started working on the smaller details on the inside, I decided that I wanted to build a mockup. Now this mockup would largely be out of regular PLA, not lightweight PLA, to save a bit of money, because the mockup wouldn't be flying. It was clear from the beginning that this mockup would never work as a plane, because the entire inside section is completely unfinished and non-existent. There were no mechanical moving parts inside of that mockup. It purely existed to serve as a reference for size, weight, sturdiness, and also just as a test of whether my 3D printer could achieve the detail and the shapes that I have designed. So the first prototype, which I ended up calling the XF-111CS, standing for experimental, is mostly just a, well, mock-up. I plan to eventually paint it and maybe put it somewhere where it's nice to look at, but really the main point was to build something to have a physical version of the model there, so that I could have a better idea of what I'm working with. After I had made some more progress with the internal designs, I started also printing actual prototype parts. The second fuselage that I was constructing would then be named the YF-111CS, since Y indicates a prototype aircraft, and things came out pretty well. However, I eventually reached a problem because the servos that I ordered arrived, and as it turns out, the dimensions that the product page showed were actually different from the dimensions that the servos actually had, which means that the cutouts that I've been designing into the model for them were actually too small, and they would not physically fit into the model as I've designed it. There were also a number of other issues with the model, mostly something to do with print quality. Lightweight PLA is a very difficult to get right material because you cannot prevent its stringing, because as long as it's heated up, it will expand and extrude even if you're retracting out of the hot end. And I've had a lot of problems, especially around where the EDF sits, with just unnecessary amounts of stringing and the surface just not being right. So I've decided to use this opportunity to not only update the servo mounts, but redesign the internal structure around the EDF fan as well, and then printing out a new version, a third fuselage, which would then hopefully become the full YF-111CS. And this is the fuselage that I'm currently still working on. So far, everything is going great. It has mounts for everything that needs to go into the plane. Really, the only thing that I am waiting on right now is a number of carbon rods that I use to reinforce the wings and the swing wing area to just make it a bit more sturdy and make sure that the loads don't tear the plane apart in a tight turn. After that, it's really just printing out the other half of the plane and then putting everything together and getting it ready for its first flight. Until that happens, it will still be some time. There are some minor details that I still need to finish designing. There are also some other parts that I still haven't ordered. I have not yet decided what sort of electronic speed controller to use, because there are a lot of them available, but a lot of them also overheat very quickly if you run them close to their maximum rating, and those EDFs pull a lot of power. So I ideally want something that is small enough to fit inside the fan ducting and not obscure the airflow too much, but also something that has enough cooling available to it so it doesn't overheat and I lose engine power. There's also a somewhat slightly annoying issue, which is when I ordered a specifically 270-degree servo that would require a servo expander to actually achieve this full 270-degree rotation, I was actually shipped the 180-degree version of that servo. It is not a massive issue, the 180-degree servo would still work, but if I use that servo, the swing wing mechanism would only be able to swing the wings back to about 5 degrees in front of where they would be fully swung back. And I'm not entirely sure if I want that. It would be good enough to test the capability of the prototypes and if the swing wing works properly, but it wouldn't be able to completely fold its wings back properly. Overall, I am fairly confident that by the next spring, this plane will be ready for a test flight. I am not entirely sure if it will fly or if it will even survive the test flight. I am planning to do a couple takeoff runs where I just pull up very slightly and then let the plane settle back down on the ground to figure out where the center of gravity needs to be on this thing and what amount of up elevator is enough to get the plane climbing, since the elevons on this plane are really massive. So turning them by just a few degrees should already give a pretty significant result. I will also have to do some testing how sturdy the landing gear is that I'm designing by myself, and generally how sturdy the entire structure of the plane is. One thing that I haven't mentioned is that there's actually no carbon rods along the fuselage. The only carbon rods inside the fuselage are actually there to reinforce the area around the swing wing mechanism, and I'm not using any reinforcements along the length of the fuselage, because I am expecting that the slightly thicker outer wall width that I'm using is enough to handle most of the loads, but that is only a theory. It worked for the Fury, but the F-111 is heavier, larger, and longer, and it's not guaranteed that that will work. So a lot of testing will be done with that first prototype. Probably a lot of it will already be done before it ever properly lifts off. Because if I try to full send the plane and then something goes wrong and it crashes, I need to rebuild the entire prototype and can't make any progress while I'm doing that. And I guess that would be it with the update for this project. Overall, I've gotten pretty far. I honestly expected this to take longer. I really thought that designing the plane and getting everything to work together would take longer than this. But given the progress I've made, that I have mostly a finished plane with most of the electronic components fitting and working, I am fairly surprised that it's not even 2024 yet and I am already this far. So I am very confident that this plane will fly next year. Whether it will fly successfully, that I can't say, but I am fairly confident that the plane will fly. Until then, I guess stay tuned, and if anything else happens that is noteworthy, I will make another video like this about it. Thank you all very much for watching.